So today we're talking about length, mass, volume, and even measurements of time. Let's get into it. I'm Mr. Cox, and today we're talking about Measurement and Data 4.1. Here's what it says. Know relative sizes of measurement units within each system of units, standard and metric, including kilometers, meters and centimeters, liters and milliliters, kilograms and grams, pounds and ounces, hours, minutes, and seconds. Within a single system of measurement, express measurements in a larger unit in terms of a smaller unit. Record measurement equivalents in a 2-column table. If this seems like a ton of stuff to focus on for just this one standard, it's because it is. It's a lot of stuff. This is the first year that all of these things are going to be taught at once together. And there's going to probably be some confusion because of that. Especially when you're going between customary, standard, and metric units. But let's quickly break it down. Relative sizes of measurement units. Simply put, a student should know by the end of this that a foot is bigger than an inch, but it's also smaller than a yard or a mile. They should also know the relative sizes of measurement units using benchmarks and mental images. For example, a quarter is about the size of an inch, and a notebook is about the size of a foot. The other thing that I've noticed here is that we're looking at measurements of time, length, volume, and mass. You can probably use the term weight instead of mass in this scenario with these kids, but don't let the 8th grade science teacher catch you. The third and final thing that we need to do is be able to express measurements of a larger unit in terms of a smaller unit. Now this is more exact than just knowing the relative size that is mentioned at the beginning of the standard. Students need to be able to say that 1 foot is 12 times as big as an inch. The important note here is that they'll cover division in 5th grade, so all you need to focus on is multiplication. They should also know that 1 foot is equal to 12 inches, or 2 feet are equal to 24 inches. Now using a 2-column table that the standard suggests is a fantastic way for students to understand and express that equivalency. The complicated thing they need to understand with this is that changing the unit, say from 1 foot to 12 inches, doesn't actually change the value. They're still the same length. They're just using 2 different units to describe the same measurement value. It's like that riddle. Which weighs more, a ton of bricks or a ton of feathers, right? Only in this case, we're saying what weighs more, 16 ounces or 1 pound? The answer is the same either way. They both weigh the same. 16 ounces equals 1 pound equals 16 ounces. Now let's rewind a bit and see what students should know coming in to 4th grade. As a reminder, this is something students should have learned. It doesn't mean that they actually learned it or remember it. This is also a great time to assess for prior understanding and fill in any gaps that they might have. Now let's start with units of time. Students should be learning about time all the way back in 1st grade, where they're going to be learning about writing and reading units of time in measurements of hours and half hours. 2nd grade introduces them to AM and PM, as well as telling time to the nearest 5-minute mark. 3rd grade introduces them to writing and telling time all the way down to individual minutes. In 3rd grade, in addition to telling time, they also need to be able to add and subtract time using word problems. This includes problems of start times, end times, and even elapsed times. Now, learning about time finishes in 4th grade, where they're learning about individual seconds. Now remember, the key thing here with this whole measurement unit is getting students to understand how to express these units in relation to each other. For example, 1 hour is equal to 60 minutes, or 1 minute is equal to 60 seconds. Recall that the main idea here is that the value remains the same, whether it's 1 hour or 60 minutes. It's the exact same value. You're just expressing it in different units of measurement. The other measurement units have more of an interesting history. 1st graders are using measurements of length, but not official units of length. They simply need to compare and order the length of several different objects. Essentially, what is the length of your notebook if you're measuring with pennies or with a crayon? Now 2nd grade continues with measurements of length, but they're using official units of length. This will include inches and feet, or centimeters and meters. They should also be able to determine the difference in length between a crayon or a pencil if you're using inches or centimeters. Third grade, they kind of shift away from length and instead start working on mass as well as capacity. They learn how to measure and estimate liquid volumes and masses of objects using common units in both the metric and standard systems. They're also asked to solve word problems involving all four operations. Now, all of this comes together in the fourth grade where they're going to be using all units of measurement. A nice addition in fourth grade is being able to teach them about conversion tables, which is going to help them switch between larger and smaller units of measurement. Now let's fast forward and see what they're going to learn after fourth grade. Fifth grade doesn't actually spend a lot of time on physical measurements. Instead, they spend a lot of time finding the volume of different shapes and figures, but instead of using the measurements that we're focusing on in fourth grade, they're going to be using unit cubes, which is a little different than what we're talking about today. The only thing that they do expand upon in the fifth grade is using different size measurements within a given measurement system. An example here would be going from 5 centimeters to 0.05 meters, which is tricky because you're moving from a smaller unit to a larger unit, which means you're usually dividing and there might be some decimal points involved, which does make it a little trickier. So what does this look like in the classroom? This standard covers a lot of different things and it's a little confusing, so it could be broken up into several different lessons, units, or even competencies. Let's start with knowing relative sizes of measurements within one system of units. My experience has always been that students will always need a small refresher on the different measurement units. I'd venture to say that you're going to have to start from scratch because they've only had 1 year of mass and volume, and the last time they talked about length was all the way back in second grade. There are some quick and easy methods to help them remember or recall different measurement unit names and what they measure, but the pivotal thing here is that you make sure they can at least compare the measurement unit to something in the real world, so they have context. This is the thing that will most likely stick with them, so make it as engaging as possible. One idea is to have them categorize different objects into what would be the best measurement unit. It could be stuff that they find on the internet, in the classroom, or around their home. For example, find 5 things around the classroom that would be best measured by inches and share them with the class. Here's some stuff I've used in the past. The key thing here for the metric system is that they need to remember these 3 things. Liters, meters, grams. Liters and meters and grams, oh my. 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 If it worked in the Wizard of Oz, it's going to work in your classroom. Everything that you're going to teach about metric hangs on knowing these 3 units and what they measure. Once you've established these 3 things, then you can move out to include milli, centa, and kilo. My bad. I thought I spelled it wrong. I spelled it right. And then I had to spell it right again. These are the 4 basic measurement units they need to understand. They need to understand milli, centa, kilo, and then the base measurements. I also like to teach all of the lesser known measurements. Even though you're teaching them more, I think when you're talking about converting measurements, this is actually going to be easier. It's really hard to teach that a kilometer is 1,000 times greater than just a meter, but then a centimeter is only 10 times greater than a millimeter, and if you're only teaching those 4 measurement units, it can get kind of hard. In order to teach you some of these lesser known ones, I'm going to teach you the King Hector method, which is just a simple acronym that's going to teach you all of the measurement units within the metric system. King Hector died by drinking chocolate milk. This is kilo, hecto, deca, the base unit, deci, centa, and milli. Now, the difficult part here, and where some confusion might come into play, are these 2 D's right here, because it's the only repeating letter, and they kind of could look or sound the same. There are some stories out there that you can read that are a book to try to get them to kind of remember what the acronym is and what it stands for. But you can make up your own story. But have fun with it. Let the students make up their own acronym for it, something that they can remember it by, or have them make up their own story using the acronym that you want to use in class. Now, the nice thing about teaching them the whole King Hector method is that the metric system is a base 10 system. So once they understand this aspect of it, making conversions is really easy once you teach them this simple trick. So here's my base. Sometimes I like to put the base names above this as well. So meters, liters, and grams. Before we start, I like to put all of these in boxes. So say I have 5 meters. I'm going to put 5 in the meters box, or the base box. Now the nice thing about being a base 10 system is that every time I move to the right in this chart, I'm just going to be multiplying by 10. So sometimes I like to add that above each line. This is going to help them visualize what they're doing every time they move to a new box. So if I start with 5 meters and I'm trying to move to the centimeters box, every time I move to a new box, I'm multiplying by 10. So 5 times 10 is 50. So I'm just adding a 0 because it's base 10. Hopefully they know when you multiply by 10, you're really just adding that extra 0. And I need to move to the centimeters box, and then I'm just multiplying by 10 again. So 5 times 10 times 10 is 500. So 5 meters is equivalent or equal to 500 centimeters. The nice thing about doing it this way is really they're just adding that extra 0 in the box, but make sure they understand that they are multiplying by 10 each time they move a box and not just adding a 0. The really cool thing about teaching them this method is showing them that when they move to the right, they're multiplying by 10, but if they're moving to the left, all they're doing is using that base 10 system but making it smaller, so they're dividing by 10, which is going to be helpful in 5th grade. The key thing with this trick is that they need to understand that they need to put the ones digit or the last digit of the number in the box in which you're starting in. So if I'm starting in meters and my number was actually 50, I'm not writing 50 like this. That's not the way to do that. You have to put 50 so that the last digit or the ones place is going to end up in the box in which you name. So if I'm starting with meters, it's going to end up in the meters box. For example, if I have 500 meters and I need to figure out how many centimeters that is, I'm going to put 500 so that my ones place or my last digit is in the meters box, and then I can multiply by 10 from there all the way to centimeters. So 500 meters is equal to 50,000 centimeters, or 5 meters is equal to 500 centimeters. This concept can be pretty tricky, so take some time and practice it with them so that they understand it's the last digit that they're putting in the starting box. Customary or standard measurements are, I think, a little more difficult because you have to remember a name for each one of the measurement systems or units, as well as all the conversion units. One thing that I use for capacity is a little song that I like to teach to all my students. This one has fun actions as well. There are 8 ounces in a cup. To get what's next, just double it up. What? Double it up. There are 2 cups in a pint. There are 2 pints in a quart. There are 2 quarts in a half gallon. There are 2 half gallons in a full gallon. I know it's a little embarrassing and weird, maybe, but the kids actually really enjoy it. One fun thing that I like to do is start off slow and then speed the song up and do the song multiple times and see how fast the whole class can do it. I know some teachers like to get kids to remember it by drawing the big G with the L's and the Q's and the P's and all that stuff. I never did that because it didn't make sense to me. So now, once you've gone through that song and you feel like they've grasped the names and the numbers pretty well, then you can write it down like this. The important thing here is writing it out like the metric system that we just did. So starting with the biggest size, which is gallon, which would be comparable to kilo, and then ending with the smallest size, which is fluid ounce, which is comparable to millimeter. If you write it out this way, then you're going to multiply if you go to the right, just like we did with the metric unit. Once again, I'm going to write my little boxes, and then I can do my conversions from here, but I need to remember the numbers in the song. So there are 8 ounces in a cup, and then just double it up, double it up, double it up, double it up. It's a lot like the metric, but instead of a base 10 by multiplying by 10, we're multiplying by 2, except for that 8. So make sure everyone understands that you're multiplying by 8 to get from cups to ounces. And this is how this one works. So if I start with 3 pints, and I'm trying to find out how many cups I have, every time I move to the right, I'm just multiplying by 2. So 3 times 2 equals 6. So 3 pints is equal to 6 cups. Or if I wanted to go all the way to ounces, 3 pints equals 6 cups, which is also equal to 6 times 8, which is 48 ounces. Or if I started in quarts and I had 4 quarts to start with, and I'm trying to get to cups, I'm just multiplying by 2, so that's 8. I'm multiplying by 2 again, and that is 16. So 4 quarts is equal to 16 cups. They don't have to learn this now, but just like with metric, anytime they move to the left, they're going to be dividing by the number. So if I have 6 cups and I'm trying to find out how many pints I have, all I have to do is divide by 2. So 6 divided by 2 is 3. So 3 pints is equal to 6 cups. 6 cups is equal to 3 pints. Again, division is going to be taught in 5th grade, so don't use this unless you're planning to use it to extend their learning. Now, inches, feet, yards, and miles are things they're just going to have to remember, as well as ounces, pounds, and tons. If you have an interesting or fun way to teach these, leave that down in the comments. I should mention they probably don't have to understand how many feet or yards are in a mile, or how many ounces or pounds are in a ton, but they should have a relative understanding of what they might measure and when you might want to use one measurement over another. Now here are some specific things that the standard says they do need to memorize and understand the conversion rates, and things that they don't need to memorize, but they should be able to use a conversion key in order to make those conversions. One other thing that they might get mixed up on is the difference between ounces that measures weight or mass compared to ounces that measures fluid or capacity. So to differentiate that, just use fluid ounces with this abbreviation if you're dealing with capacity, and use ounces with just the OZ if you're talking about weight or mass. Now remember, each of these measurements needs to have a real world comparison attached to it. That way a student can quickly understand which measurement unit they would use to measure something in real life. Once students have a solid understanding of measurement units and their conversions, you can then pivot to the 2-column conversion table. The 2-column conversion table is actually so easy to teach once they master the actual conversions. It's pretty simple. You just have to start with your first conversion and then do multiples of those numbers in each column. If you've already taught them multiples, then this is a very easy way to recall that information and help them with all of this. If you haven't taught them multiples at this point, this might be a good time to actually teach this to them. So the way I use a conversion table is if I'm going from feet to inches, I'm going to put those measurements in my boxes, and I just start with my first conversion. Hopefully they understand that at this point and know that 12 inches equals 1 foot. And then from there, I just do multiples in each box. So if I start with feet, my multiple is multiples of 1, so I'm just counting by ones. 1, 2, 3, 4. And then for inches, I'm counting by 12s. So 12, 24, 36, 48. So with this conversion table, I can already see that 2 feet are equal to 24 inches, or 3 feet are equal to 36 inches. I can do the same thing with ounces and pounds. I know that 1 pound is equal to 16 ounces, or 16 ounces equal to 1 pound. And it doesn't really matter which way you do this box. As long as you start with the correct conversion, then you're going to be able to easily complete the whole table. If I draw the rest of my boxes here, all I'm doing is doing my multiples. If I'm just doing multiples of 1, I just know the next one's going to be 2, and 3, and 4. 16 might be a little difficult for them to understand that, but that's pretty easy. You can teach them, instead of doing multiples, just say, okay, Well, just multiply 16 times the number in the box. So if they've already learned multiplication at this point, you can just teach them how to do it this way. Make sure they're using this first number and then multiplying it by what's in the next box. So 16 times 3 would be 48. You can do that all the way down. So that's two ways to use a conversion table. You can just do multiples down each side, or if you can't do a multiple, like we saw with 16, they don't know their multiples of 16. All they have to do is multiply that 16 by whatever's in that box. And that's really an easy way to do conversions. As long as they know that beginning conversion, they can convert from whatever number to a different measurement unit. That's pretty much it for measurement and data 4.1. There are definitely ways in which you can extend their learning beyond what you see in this video. I mean, we're only scratching the surface here. If there's a fun, interesting, or engaging way you like to teach this in your classroom, then leave a comment. Keep the conversation going. More resources are found below, and happy teaching, everyone.